Ooh. Don't want to waste water. Well, today I'd like to talk to you about capacitance. The word capacitance is a bit like the word capacity. My water bottle has a capacity of 1 liter, or 1,000 milliliters. That's how much water it can hold. The faucet over there can just keep pouring and pouring water out indefinitely. Well, I guess maybe the reservoir might run out one day, so wouldn't want to waste water. There's a similar analogy with electricity. We can think of electricity, the flow of electrons, is a little bit like the flow of water. Batteries provide an indefinite amount of electricity. They keep providing it. Now, they can run out too, just like a reservoir can run out, but for the most part, they raise electric charge to a higher energy. On the other hand, we have these things called capacitors, which are a little bit different. They simply store electricity the way a water bottle stores water. So let's see the difference. Here's a light bulb. When electricity passes through it, light goes on. It's a load. We can hook it up to a battery, and the battery will power the light indefinitely. The battery keeps making electric charge, positive electric charge at the positive terminal. It flows to the negative terminal. When those charges go through the battery, they get lifted back up in energy, and they get to complete the circuit. So this can just keep going and going and going, no problem. It's quite bright. On the other hand, let's compare that to a capacitor. Here's a capacitor. It's not charged right now. And when I hook it up to a light bulb, nothing happens. It's now hooked up. The light doesn't shine because there's no charge in the capacitor. However, all I need to do is touch this capacitor to a battery, and the capacitor charges. Ready? Okay, it's touched. Ooh. You see how charged it looks? Well, of course, it doesn't actually look any different, but it is charged. Let's see about that. If this capacitor is charged up, it now should be able to power this light bulb. So there we go. A capacitor powering a light bulb, but notice something. The light's going out, isn't it? It's getting dim. That's because the charge that was stored in the capacitor on its 2 plates, a positive and negative plate, has depleted. That means that the positive charge has flowed through this load and then gone to the negative plate, and now both the plates are neutral. That would be like me running out of water in my water bottle. So that's the difference between capacitors and batteries. Capacitors are very useful. You see them all the time in circuits. Sometimes they're cylindrical, like these ones, but they have all kinds of other shapes. There's some very large ones and some really small ones. The small ones have a very small capacitance usually, and there's different parameters that you can get for them that have different uses in circuits. The unit of capacitance is the farad, but most capacitors, like these ones, have a capacitance of much less than 1 farad, maybe a microfarad. This one is 4,000 microfarads, so that'd be about 4 millifarads. So that's the difference between capacitors and batteries.